Good afternoon, my dear students. Yesterday, because of some technical problems, the total video length was of 51 minutes, but after 42 minutes it was dead. It was neither visible nor audible. So I'll be continuing today with the same. So I was doing with the classification of base, and on the basis of the strength of alkali. Bases are two types. They are strong alkali and weak alkali. Strong alkali, when dissolves in water, they gives high concentration of hydroxyl ions. For example, sodium hydroxide and potassium hydroxide. In other means weak alkali, when they dissolve in water, they give very less amount of hydroxyl ions. The concentration is very low. So they are weak alkali, for example, calcium hydroxide and ammonium hydroxide. Now I'm going to talk about acidity of a base. So what is acidity of a base? Number of replaceable hydroxyl ions or molecule of base content. That means when a base is dissolved in water, how many hydroxyl ions or molecule of the particular base gives. That is its acidity. So acidity of base is equal to number of replaceable hydroxyl ions or molecule of base contains. Now, on the basis of acidity of a base, they are of different types. For example, monobasic base. Monobasic base is a base whose one molecule, when dissolved in water, produces only one hydroxyl ion. For example, sodium hydroxide. Sodium hydroxide in water. Sodium hydroxide in water, aqueous in water, gives Na plus OH minus. So we can see here only one hydroxyl ion is produced by all molecule of sodium hydroxide. As a result, this is monobasic base. Any other, that is potassium hydroxide, when dissolves in water, this also gives plus OH minus. Only one hydroxyl ion it is producing, means OH is also monobasic base. Monoacidic base. Monoacidic base. And NH4OH also, when dissolves in water, gives ammonium ion plus OH minus. So ammonium hydroxide also produces one hydroxyl ion when dissolved in water, means NH4OH, that is ammonium hydroxide, is also a monoacidic base. Now let's see for diacidic base. Diacidic base. So what is diacidic base then? The base which have two replaceable hydroxyl ions per molecule when dissolved in aqueous solution or when dissolved in water. So this is diacidic base. For example, calcium hydroxide, when dissolves in water, it gives Ca2 plus 2OH minus. Means how many hydroxyl ions one molecule of calcium hydroxide is producing? 2. So calcium hydroxide is diacidic base. So that means simply you can see here 1, so monoacidic, 1 monoacidic, 1 monoacidic, 2 diacidic, then magnesium hydroxide in water again, Mg2 plus 2OH minus. Here also this magnesium hydroxide is also diacidic base. And then triacidic base, by the name itself, tri. So when a molecule of this base dissolves in water, it can produce 3 hydroxyl ions. So for example, FeOH whole thrice. When these dissolves in water, it gives Fe3 plus 3OH minus. Similarly, aluminium hydroxide. When it dissolves in water, it also can be 3 hydroxyl ions. As a result, aluminum hydroxide is also triacidic base. Now we'll be doing preparation of base. So how the base are prepared. Preparation of base. Number 1, by metals. For example, metal plus oxygen. Oxygen gives base. That is metal oxide. For example, in metal, sodium plus oxygen gives sodium oxide. Let's balance. Sodium oxide. This is a base. Then magnesium plus oxygen gives magnesium oxide. So this is also a base. Now number 2, reactive metal plus water. Reactive metal plus water gives alkali, that is base, plus hydrogen gas. So reactive metal plus water, that is alkali plus hydrogen. Reactive metal, for example, sodium, potassium and calcium are highly reactive. So I'm talking about that. When they react with even cold water, the reaction is highly explosive. Why? Because they form hydrogen gas, and hydrogen gas is highly inflammable. So sodium reacts with even cold water to produce sodium hydroxide, which is alkali, and all alkalis are bases, plus hydrogen gas. Let's balance this. 2, 2, 2. And potassium plus water, cold water. This water is cold water. This water is also cold water. Regarding all these things we have done in class 9 also. So 2 KOH plus H2. Then calcium plus water. Calcium plus water gives calcium hydroxide plus hydrogen gas. So in this way, reactive metal reacts with water to give base plus hydrogen gas. Again, number 3, metal oxide plus water. Metal oxide plus water also gives base. Especially alkali. So metal oxide, sodium oxide plus water gives sodium hydroxide. So balance here. Then potassium oxide plus water gives potassium hydroxide. Whatever reaction sodium has, potassium will have the same type of reaction because they lie in the same group. Now calcium oxide plus water also can produce calcium hydroxide. So metal oxide, especially metal, reactive metal. So metal oxide plus water also gives base, that is alkali. Now salt solution plus alkali. Salt solution plus alkali. Number 4, salt solution plus alkali. Alkali, which is a base, can give salt plus metal hydroxide. Metal hydroxide, which is a base. Salt plus metal hydroxide. Now, for example, ferric chloride plus alkali NaOH gives salt of Fe, the salt of sodium with chlorine, so NaCl plus FeOH whole thrice. So this is a base and this precipitates because it is insoluble in water. So OH3, so 23, then this also will be 3, so Na3, Cl3, Fe1, OH3, okay. Now aluminium chloride plus ammonium hydroxide, which is also alkali or a base, reacts to give ammonium chloride plus aluminium hydroxide, which is also insoluble in water, and it is insoluble in water, so precipitates the solid. So here Cl3, so Cl1, so make this 3, so nitrogen 3, so make this also 3, nitrogen 3, chlorine 3, then aluminium 1, OH3, balanced. So this way, salt solution plus alkali gives salt plus metal hydroxide, which is also a base. Now number 5, decomposition by decomposition. Metal carbonates on decomposition, on heating. Metal carbonates on heating gives out carbon dioxide and metal oxide. So metal oxide, which is a base, plus carbon dioxide gas. Now metal carbonate, calcium carbonate on heating gives calcium oxide plus carbon dioxide gas. Similarly, zinc carbonate also we can take, or copper carbonate also we can take. Copper carbonate on heating gives copper oxide plus carbon dioxide. Now you must be thinking why we are not using here sodium and potassium carbonate. Sodium and potassium carbonate do not decompose on heating. I am writing here sodium carbonate and potassium carbonate do not decompose on heating. That's why we are using calcium carbonate, copper carbonate, so on. So then by decomposition, metal sulfides also, metal nitrides also. Now metal nitrates on heating gives metal oxide plus nitrogen dioxide plus oxygen gas. Here we can use calcium nitrate on heating gives calcium oxide plus nitrogen dioxide plus oxygen gas. Then similarly we can do this with this one also, lead nitrate also. Lead oxide will be getting then nitrogen dioxide, then oxygen, and then this way we can make metal oxide plus nitrogen. When we are heating nitrates, nitrogen dioxide will come out. When we are heating carbonates, then carbon dioxide gas will come out. So this was number 5, number 2. Now some of the sulfides also. Metal sulfides plus oxygen also gives metal oxide, that is a base. Metal oxide, that is a base, plus sulfur dioxide gas. So metal sulfide, zinc sulfide plus oxygen can give zinc oxide plus sulfur dioxide. Zinc oxide plus sulfur dioxide. So 2, also 2. So zinc 2, sulfur 2, sulfur 2, oxygen make it 6. 2 and 4, 6. Zinc 2, sulfur 2. Okay. Similarly, lead oxide, lead sulfide plus oxygen gives lead monoxide plus sulfur dioxide. Lead 1, oxygen gives 2, is 1. So make this also balanced. So 2, then oxygen is 4 and lead is 2. So this is 2, then this is 2, then lead 2, sulfur 2 and sulfur 2. Oxygen 2 and 4, 6, so here also 3. So this way we can prepare base by reacting metal sulfides with oxygen. Now one more is there, that is ammonia gas when we dissolve in the water. So ammonia is soluble in water. So ammonia gas when dissolves in water can produce ammonium hydroxide. Ammonia gas when dissolves in water. Number 6, 7. Ammonia plus water gives ammonium hydroxide. So simply here we have to dissolve.